Hi everyone, this is Mr. Lee. In this video, we are going to look at a Newton's second law problem. This is the multi-body problem. And in this problem, we have three objects. We have a 2 kilogram object, 4 kilogram, and a 1 kilogram object. And in this problem, there's a force of 28 newtons being pushed on the 2 kilogram object. All right, so what I want us to be able to do with this one is when you're approaching these problems, and this is a pretty common type of problem, there's going to be a couple of pitfalls that you might fall into if you are solving the problem correctly. Meaning you're doing all the steps correctly, but you might come into a situation or two. Okay, so what I wanted to show you is not only how to solve the correct problem, but what you should do if you run into a little speed bump there. Okay, so let's begin. So we're trying to see how much force the 2 kilogram is pushing on the 4 kilogram object. Okay, so in order to start off, what I want to do is the problem doesn't tell me what the system is, so I'm going to define the system. So I'm going to define the system. I'll do this in green, right? So this is my view. I'm looking at the system as a whole. So if I look at the system as a whole, this is my free body diagram. So it's 2, 6. So the total mass is 7 kilograms, and we have 28 newtons being pushed this way. And of course, we have our normal force up, and we have our Fg down. And F of G is just your mass times the acceleration due to gravity. So this should be 70. And because we're in equilibrium along the y-axis, our normal force is also going to be 70. Okay, so what this shows us is that we only care about the x-axis net force. Okay, so knowing this, right, so I'm just looking to see what kind of information I can gather. So if I use my formula, F equals ma, okay, I know that I only have a force of 28 along the x-axis is equal to the system's mass, which is going to be 7 and a. Okay, and from here we know that our acceleration is 4. Alright, so this is part 1 of the solution. I'm going to do a quick little detour there. So you might be thinking, wait a minute, this isn't solving for the force that the 2 kilogram is exerting on the 4. Okay, we're looking at the system as a whole. Why did you do that? So the important thing here is if you take a look at the context of the problem and the formula that we have, F equals ma, there are a total of 3 variables. If you look at what the problem wants F, which is your final solution, and the problem gives you the masses. Okay, so if we take a look at the formula here, we're looking for F. This is a known, but this A is a unknown. And so in a situation like this, if you have 2 unknowns, you can't solve the problem. And so what I did is I wanted to solve for the acceleration of the system as a whole. Now you might be wondering to yourself, Mr. Lee, why are you looking at the system as a whole? Why not on just a 2 kilogram object? Well, if we did look at just a 2 kilogram object, we'd run into a very similar type of situation. Okay, so if you take a look at just a 2 kilogram object, where we have that 2 here, there's a force of 28 that's being pushed to the right. We have our normal force of 20 and our F of G as 20. Okay, when this when this 2 runs to the 4, okay, the 4 will push back on the 2 to the left. Okay, so I'm going to label this the force of 4 on 2, and that's what the problem is looking for, right? But we don't know what that is. That's the final solution that we're looking for, because if you look at the problem, it's the force of 2 kilogram exerts on 4 kilogram, but according to the third law, right, F of 4 on 2 is equal to F of 2 on 4, but with a reverse sign. Okay, so we take a look at this situation here, and if we set up our formula, okay, we run into a little situation. We have 28 minus F of 4 on 2 is equal to, so this is just the 2 kilogram object, so 2, and then once again, we have that A. Alright, so same kind of problem. We have 2 unknowns. Okay, and so this the same unknown keeps on popping up over and over again, and that is the acceleration. So we need to know the acceleration of the system. Now keep in mind, acceleration is not the motion, okay? Acceleration is how that motion is changing. So whenever you say motion or moving, this equals velocity, but acceleration is not velocity, okay? Velocity and acceleration, not the same thing. Acceleration describes how much that velocity is changing. Now, here's the thing, okay? We know that all of these objects are experiencing the same acceleration. So by finding the acceleration of the system as a whole, I know that the 2 kilogram object has an acceleration of 4 meters per second squared. The 4 kilogram object has the acceleration of 4 meters per second squared, and the 1 kilogram object has an acceleration of 4 meters per second squared. So at this point, what I can do is, knowing that this was the very first thing that I did, and knowing that I found the acceleration, now I can plug in my acceleration here. So I get 28 minus f of 4 on 2 is equal to 2 times 4, which gives us 8, and therefore f of 4 on 2 is equal to 20. Now, this actually does not tell us the actual answer, because remember, the answer is looking for the force of 2 on 4, but according to the third law, this is equivalent to the following, but in reverse magnitude. Okay, or yeah, reverse direction, not magnitude. Okay? All right. So that's the method to solve it. Now let's talk about a couple of the pitfalls, right? So if you're looking for the force that 2 kilogram exerts on the 4 kilogram, you might be tempted to draw a free body diagram of just the 4 kilogram object, okay? And so if you remember from the very beginning of the video, I did mention if you run into a couple of these speed bumps, okay, those speed bumps just tell you just got to look at the problem through a different view. So if we were to do a free body diagram here, we have f of n, which would equal 40. We have f of g, which is equal to 40. But now if we take a look at the situation, we can say that this 2 kilogram is pushing the 4 to the right, and we also have this 1 kilogram object that is pushing the 4 to the left. So we have two forces acting on that object. So I'm going to draw that here. This is the force of, what was that? That is the 2 on 4. Okay, so this is the force of 2 on 4, and this is the force of 1 on the 4. Okay, and so if we take a look at the situation here, even though this force is what we're looking for, right? This unknown force is what we're looking for. If we set up the problem, we run into the same situation. We have too many unknowns. We know that our m is 4. Okay, if I didn't find the acceleration first, we have a unknown acceleration. This is the unknown that we're looking for, and then we have this force that is also unknown. Okay, so at the end, the strategy here is, when you set up everything, right, as long as you set up everything correctly, you might run into situations where you have one too many unknowns. And if you have one too many unknowns, all that means is that you got to try a different method of solving it so that you can find that unknown variable to get you to the final correct answer. Unfortunately, for us, it's not as simple as here's the situation, plug in the numbers to get the answer. There's going to be a couple of extra steps involved. All right, with that being said, I'll see you next time. Bye-bye.